So in this talk, we're going to talk about private inference. So actually for private inference, it means two things. So one is you can make sure all the inputs and outputs is private. So you don't need to worry about anyone spying on the data you give to LLM. But on the other side, how can we convince that this is really private? So that's another question also closely related with private inference itself. So that means we need to somehow get a proof. So we're going to be convinced only after we receive the proof. And during that proof, there are a lot of things we can do. For example, we can prove what is the LLM you are requesting. Like if you pay for GPT 5.6, then you are not going to just pay for GPT 3 model, right? So yeah, great opening. What is private inference? So if you, I believe like everyone here has been using ChatGPT for a long time and you use AI all the time. And whenever you give something to AI, like OpenAI or Anthropic, they can see everything from your inputs or even the LLM outputs. Maybe they can promise that we're never going to see your data, but that's just a promise. Technically, any like backend engineer, as long as they have the access to the data itself, has the access to the hardware itself, can actually see what's running inside. Because that's just a promise. It doesn't mean they can enforce this promise. So what if we want to make the LLM inference purely private? So one way is, of course, you can deploy something on-premise. You can buy your own hardware and run that without any internet. So that's good. But if you want to run any real serious model like GLM 5.2 or Kimi 3, you'll probably need to spend the $500K just for a single box, like a B H200 to run that. So that's too expensive. And also, even if you want to get some GPU, you're going to wait for maybe half a year to deliver because GPU is so hot and you can barely find any single available GPU right now. And another way is you can go to the cloud, right? Cloud providers, but then you essentially give your data to the cloud. Whoever operating the cloud can see the data. So is there a way to still enable the privacy without really buying the super expensive Hopper GPU? And the answer is that we can have a combination of confidential computing with cloud compute, so that you don't have to own the hardware, but you can still prove that everything that runs is still in the TE, trusted execution environment, and your data never gets out of the trusted execution environment. So, well, probably we don't have to explain what is a trusted execution environment a lot, but basically it's like a black box. It's the CPU, it's the GPU. You can turn that on, and once you turn it on, nobody else can see the data you gave into this hardware, not even the hardware administrator, or even if you have the physical access to the hardware, because everything is secured using encryption and the proper isolation. So yeah, that's basically TEE. And you can imagine if we put the model running in the TEE, and on the user side, on your side, you encrypt everything, send the ciphertext to the TEE, and the TEE get it decrypted and run the computation and return you the results in the same way. Then this essentially makes sure, to some extent, nobody else can see your inputs or outputs. Of course, we're not seeing the very extreme cases where maybe some hackers can hack into the hardware itself. But there, this sounds really good, right? You can have you don't have to own the GPU, but you still can get a lot of. Yeah, you don't need to own the GPU, but you can still get a lot of computation. You just need to pay for the token. But why don't we see a lot of confidential computing providers out there? So the biggest problem is there's a big challenge. That's the capacity. So there are a bunch of confidential computing providers like us and a few others like Near AI, Truth, or Tinfoil. And none of any provider has like thousands or even tens of thousands of GPU. And if you use, say, like an AI agent. The AI agent can simply spin up a few sub-agents, and they can send parallel requests. It can easily saturate a few GPUs at the same time. And as a result, if we don't have enough capacity, you just feel, okay, why if I send some simple request to confidential computing GPU, it just tell me run out of the capacity. It can serve and you have to retry. And this gives people a really bad user experience. People will say, oh, probably that's because the TEE, the confidential computing, which gives a very bad performance. But this is not true. It's just because there's no many confidential computing backing the LLM API. And as a result, we probably lose users. And if we lose user, we got no revenue, and then there's no capacity. So this is like, we need a flywheel to break this challenge. If we can have more capacity, then we get good user experience. We get more users, we get more revenue, and then we can invest into the GPU. So everything can get to something that's really useful. But this is like a chicken and egg problem. How can we bootstrap such a huge capacity before we have a lot of users? So one way to get it out is that we can try to aggregate, just like how we have aggregator for non-TE models. If you go to Open Router, they have a few, like roughly close to 100 of providers. And you send a request to Open Router, and Open Router just try to figure out who has the capacity, who can give you the best results, and then route your traffic into that. So we want to do the same thing. If we can have an aggregator, but this aggregator is trusted execution environment native, it's confidential computing native, then you don't need to worry about who is serving your request. As long as the request can arrive on the GPU privately, securely, and then it gives you the good user experience, then it's good. But in confidential computing, a big problem is that it's not as simple as I just run like a load balancer. And whenever you give me a request, I find an arbitrary provider and send your request out. Because another part of confidential computing is to make sure we can prove everything, right? So we don't just serve, we also prove. If, say, for example, we have a pretty, sophisticated architecture. On the right side, we may have a few GPUs, and on the left side we have the user. How can we prove those GPUs are serving privately and securely? At the same time, we can aggregate those GPUs and route the user traffic. So the problem is that we need to make sure from the user to the aggregator to the GPU, this whole process is secure and private. And the GPU can prove it's private, but it's not enough. We still want to make sure the router itself can prove the entire link is private. So that's why we need a way to make sure, no matter this is provided by FA, by NEAR, or by some other providers, the user can understand those are the proof. Those proof combined can make sure you trust your prompts will never get out of the trusted execution environment. And to make that possible, we made a new project called the Private AI Gateway. This is under dstack organization, and it's fully open source. So essentially, what we need is we need to have a backend, and this backend is responsible to understand who are the private inference providers, like the GPUs. It can be GPU. It can also be another, like a service. As long as we can prove the upstream itself is secure and private enough, then we can route traffic to them. And the other half is the user-facing side. The user wants to talk with, like the load balancer or the gateway, but the user also wants to verify the entire system. So we get all the proofs from the upstream, combine them together, and then we can also get the proof for the gateway itself. This is also running in the TDE. Combine them and then serve to the user. So that's why here we have a few purple colored like lines. So all the purple colored lines means that this is a tested section or a tested channel. This is a channel. It's end-to-end encrypted, and then it's not only encrypted, but any those channel can make sure the client can verify what's running on the server side. So if we have this, then we can have everything. We can have something very interesting because we can have not only one single gateway. The user can route to a few upstreams. We can also have like a combination interoperable gateways. So for example, we may have another load balancer, and this load balancer just have a single purpose, that is to load the route the traffic between a few GPU TE and make sure that the traffic is optimized. So the gateway itself becomes like a building block, and we can freely combine them anyway to make sure the entire system is secure. And from the user side, you don't need to verify everything. You just trust your counterparty. Like the user connects to this gateway, so you verify this gateway. And this gateway is in charge of verifying all the upstreams, including the direct GPU provider, another gateway. And this gateway is in charge of verifying its own providers. So in this way, we combine a network of the TEE to make sure you can almost extend this network in an unlimited way. And yeah, this is actually already explained. So near AI, tinfoil, Fala, Truth, everyone has their own language for proving their own system. And of course, as a user, you don't want to verify all of them. So how? Then we just use this gateway to aggregate all the upstreams and provide a single unified user interface to API to the user. And this is already live today. So Red Pill is actually one of our products built by our team. It's like an open router, but it's confidential computing mode. So you can see if you enable like TEE model, then all the models are TEE, no matter where it comes from, can come from us or come from the others. And we're doing that in a very serious way because, for example, if you check open router, we're one of the open router provider, and we're selling like roughly 5 to 10 billion amount of the token every day on the open router. And you can find the implementation. Oh, let me check if I can open that. Okay, nice. So you can find the implementation here. So dstack is the organization. It includes the very low-level dstack infrastructure and also this private AI gateway. And if you click here, you can see this is the implementation. It's fully open source, and you can run that in any supported TEE environment. And here we do have a spec, and welcome any feedback. So because we want to make sure, if those model providers, they're going to talk with each other eventually, and then how can we make sure we have like a shared common interface and make it useful? So it turns out we have created a specification called ACL, Attestation Confidential Inference. And it defines a few interesting things like the trust model and how do you identify the identity, and how do you present the attestation to the user, and how do you do the protocol level end-to-end encryption. And another very interesting thing is that in the documentation side, we have already integrated with a few providers. So like Choose Near AI, Secret AI, tinfoil. And for every provider, we have like a table to just make sure their implementation actually meets our standard so that they can be included. So for example, if we click one of the review page, we basically have a checklist for all the upstream providers. And we verify everything, including what is running in the confidential computing environment, and how can we make sure there's no backdoor, and how can we make sure it's end-to-end encrypted and the TLS terminates within the TEE. And if there's like a new provider to join this network, just simply make a pull request, and then we can include them in this provider. And then once it's included, it can serve on Red Pill or whoever use the private AI gateway for the private inference. Okay, I think I have to go back. All right. And then there's also some other links like on Red Pill AI models. You can see all the models we're already supporting. Oh yeah, I should show you this. So for example, for GLM 5.2, we already have multiple providers here, and you can see we have the monitoring. And this is Red Pill, and finally Open Router. If you use Open Router and choose a zero data retention, then you can see we are one of the providers there. All right. So yeah, very happy to be here, and thanks for listening. That's my lightning talk.
We have a bunch of questions from in the back. That's actually really convenient screen. So we all just kind of like fit in on it. So Jonathan.
Yeah, I suppose we had like a simple question on whether you have usage stats. Do they come from people who want like a ChatGPT type experience in T, or is it more like agent to agents who are trying to find guarantees where they are outsourcing tasks to another, for example? Did you want to do that one first? Yeah, go ahead.
Yeah. So based on our feeling is that the usage of the token, if you measure based on total number of the token, by far the agent consume way more token than human. And on the other side, we also have a few like downstream. They use our API to build their own services. One of that is Venus. So they use our API to run their, they offer something very, very similar to ChatGPT, but privacy oriented. But maybe 90% of the usage still comes from agents and the agentic coding.
Did I second? On the routers side of things, because like we were talking about compute markets before, and it seems to me that all of the countries you were showing, yes, they all TE enabled, but if you think about the threat model of the different TEs they're using, and even how they're deploying them, they're not really functional, right? So in a compute market, in this kind of like router API that you have, how can I know what I'm actually buying and what also these things?
Yeah, that's a great question. So typical case is that you rarely find people cheat using when on this I mean not only limited to the TE model, but also like Open Router. If you are requesting Kimi, it's very unlikely people give you another model. But the nuance is like even for Kimi, K2.6, maybe you have like a hyper quantized model FP4, FP8, and they have different, like intelligence and different performance, basically different quality. So on our side, we do have two kinds of requirements. So one is absolute security. So like I shown here in the ACI spec. So if someone can't prove that the user prompt will never get out of the TEE, then we are not going to list it. So for example, one nuance is that if say someone runs something in the TEE, but then the next day they can run an upgrade and then swap the model into another, and maybe even adding some backdoor, then this doesn't meet our standard, and we're just not going to list it or merge that into the private AI gateway. So this is the security side of this. Another thing is you want to know what you are buying. So this is the proof side. So like if I show here, those purple colored lights means a tested session. So all the session give you not only the encryption, but also the proof. You can see what's running on the target. So for example, this is near. So through this connection, we can see what's running by near, right? And in that attestation, you can actually trace it back to the launch parameter. So it will include where you download the model. Do you download it from Hugging Face? And which model are you using? Is it the FP4 or FP8 model? So everything is traceable and auditable. And on the gateway side, we just make sure all the evidences are stored. So if a user wants to check it, they can request the original evidence, so they can be sure what's running. And of course, as a user, you can also say, I'm only going to send the request to Fala, but not maybe another provider. So it's up to the user.
Who's writing these errors? Do you, or is it each of the providers?
Each of the providers.
So that's kind of like relevant as well, right? On touch. I guess you've seen like the recent papers on each handshake, for example, that's proof that there's different grains of security depending on how you implement the attestation. Is the TLS work. So as a consumer, how do I reason about that when I'm using your product?
Yeah. So this is a good question. So we're not dealing with that yet. So I would say ideally, so here in this major way, we can actually have some customized logic. And this logic can include, for example, some benchmark, like quality benchmark, or like at the business level, you can have arbitrary business logic implemented here. For example, faster model you charge higher, a slower model you charge cheaper, right? So this can be customizable. But at the private AI gateway level, we just make sure the primitives are there. So the user can specify you just want to talk with maybe this provider, but not the other provider. You can do that. Thank you.